Okay, you should see that we are recording. Does it say on your screen that I'm recording?
Yes. Yep.
No swearing. Okay, we'll go in. Same order as before.
Same order.
And hello, everybody, and welcome to another E5 podcast. It's part 2 of our Brady Bunch special, all the way from the UK and the Americas. Hello, everyone. I'm Paul Meenan, and I'm joined by my regular tag team partners. Introduce yourself.
Hello, I'm JW.
It's Dave here, Sparky Ninja.
And it is not the same day. We have all stayed in the same clothes in the same position for an entire week to bring you this second part to talk more about earthing and bonding. But I am joined again by our colleagues from Earthing Services and SAE. Please introduce yourself, chaps.
Hi, I'm Sean Elliott-Mayer. I'm a director at Earthing Services, overseeing operations and communications. And Earthing Services is the European partner enterprise of SAE.
My name is John Mayer. I look after the technical wing of Earthing Services.
I am Todd Sorolla. I'm the CEO of SAE, and we specialize in grounding both from an engineering perspective, and we do product development as well for grounding systems.
I'm Chris Cox. I'm the power utilities specialist for SAE. I bring 30 years power utility experience to the conversation.
And I'm Rylan Boyd, engineering manager at SAE, and I complete a lot of the field work as well as the in-house design for power utilities, telecom, oil and gas, things like that.
Okay, brilliant. Well, we've lost one of your colleagues. He's has other pressing matters, but we shall continue onwards. Now, in the last podcast, we talked about the Conjudisk and its innovation. And I just want to highlight, if anybody hasn't gone online and actually looked up SAE and Earthing Services, one thing I do like is underneath their logo is the statement, "It can be done," which I really like. And I like the fact that they put innovation, reliability, and value. Because for me, the best definition of innovation I've ever seen, and there are lots of them, is something of benefit to a business. And if you can reduce safety risks and hazards, reduce your capital expenditure, reduce your civils work, this is why I wanted to get you guys on to talk about the Conjudisk. But it's not just the Conjudisk that can give innovation, reliability, and value. We've got lots of other stuff. And in this episode, what we're going to do is we're going to grill you on all the other products that you've got and all the technobabble around it, and talk about other types of earthing. So I want to talk about something mentioned during the last podcast, which is Conjucrete. So who wants to introduce us to the wonderful world of Conjucrete? Because all the civil engineers that are listening may be getting excited now.
Okay, I guess that would be me. Essentially, Conjucrete, as the name suggests, it's a conductive concrete. And based on the amount of water that you introduce to the product, you can get sufficient strength to do structural work. And one of the things we're doing with it most recently is we're using conductive concrete to actually set direct buried steel poles. So you set the pole, if you're using a galvanized steel pole, which most are, or some other form of metal as the structure itself, then you can make the pole itself the ground electrode. And you also, by using the conductive concrete, because it has very low permeability to water, it protects the steel against corrosion. So that's one of the latest things that we're using Conjucrete for. But it's also used to improve surface area on more traditional ground electrodes as well. So the material, again, it's conductive. it allows you to increase the surface area simply by, if it's a horizontal, you make it perhaps a ½ meter wide, install it roughly ½ meter deep at a minimum. Essentially, any electrode that you put in, if you use the conductive concrete around it to impact its overall diameter or its width, if you will, on a trench, you basically have a much larger surface area electrode, and at the same time you protect the metal against corrosion. So the life expectancy is roughly about 20 times what a bare copper or bare metal electrode would be in the same circumstance.
So it's worth saying in England, a lot of guys, and I know this from when I was an apprentice, they would go out, if they had to get a rod, they'd put something called bentonite in, which would help the rod. But if you look on your website, it's one bag of Conjucrete is the equivalent of 84 bags of bentonite. So this stuff is far lower impedance supportive than what we traditionally use in the UK, which you combine that with Conjudisc, you've got something pretty darn special. I think that's fair to say.
Yes, and the other thing about comparing our material to bentonite is that our material does not shrink. So of course you have to be concerned about what happens over time with bentonite, because the moisture content changes, then the material will expand and contract, and in some cases it will pull right away from the core of the electrode itself, and then of course it's not doing as much for you.
Just going to say, John's got a great story about bentonite, and again I'm just going to remind him that we're going to not name locations. We're not going to look to we're going to spare everyone else's blushes, but yeah, John.
Right. Well, I had occasion, well, more than one occasion, where because of the underlying rock being close to the surface, we couldn't drive earth from electrodes. So we've got a copper plate and we've got plenty of bentonite. But the real problem we had was because we're in the high street, the slabs of the pavement had to be reinstated immediately, where as soon as the slabs were put down, the bentonite started to expand. And over the next day or so, we created what can only be defined as a steeplechase for horses. Everybody had to be jumping over these slabs as they were coming out of the ground.
So just raise the slabs up.
Yeah.
Wow.
And there was another one to extend an earthing system on one of their sites. And same thing, they dug a trench all the way down to the gate for a copper tape in, put plenty of bentonite over that, and immediately they reinstated the drive with tarmac, brand new tarmac. And over the next few days, we had a ridge that came out of the surface that was about 6 inches high from the station all the way to the gate. Very good product.
It's worth pointing out that we've dusted off an old story here. This is before the advent of Conjucrete and our association with SAE. But bentonite's an unpredictable beast. It's a clay. I mean, I have a different use for bentonite, which is one of its more common uses all over the world. I use a bag of it every week. It goes in my cat's litter tray, and it's wonderful. It's it'll absorb my cat's waste, and then we just scoop it out and clear it out. So it's a wonderful product. I just think there's a better one for earthing.
Hang on a minute, John. Cat data. You're not using bentonite, are you?
No, he goes outside in the garden.
Chuck some bentonite down; it'll absorb it easier.
I do remember though, John, you referencing cat litter when you talked about bentonite once in the video.
I mean it is the same material, so it's there's nothing wrong with it for that. But do you really want to be using that in your earthing structures for your building? Probably not.
No, not if there's an expansion contraction issue. But one thing I do like is the comparative reference between bentonite and Conjucrete. Is bentonite is in the hearts and minds of the analog era, and yet Conjucrete is very much the mindset of the digital age. And the analog era, as I said previously, we sometimes make the same mistakes again and again because we've always done it that way. Or, dare I say it publicly, the construction infrastructure industry has a tendency to cut and paste what we've always done and hope that's good enough without thinking about the actual location specific hazards, the needs of the end user, the specific needs of the building, the safety operations. That engineering competency gets lost, but then gets, funnily enough, recalled when something goes wrong at the end and there's an incident, and you get someone who is very intelligent going, well, you should have done it like this at the start. And earthing and bonding is a system, not two separate silos that you could contract. I have seen earthing contracted out and bonding contracted out separately under two separate contracts before. Okay, when I first started on railways, it was just madness. It was a very, very long time ago, but this is the hazards of procurement. But we could do an entire podcast on the hazards of poorly procuring engineering services. And I think that would be a global podcast, just to be clear.
Yeah, we'll come back.
Yeah, we'll come back on that one. I'm going to turn my attention to Chris though, because you made a little comment offline, because we have a chats offline about one of the biggest, and this is a UK issue as well, when we're doing alterations or additions to an existing infrastructure, people use the term upgrades, when in actual fact what you should do is, if you're working from the regulations or the code, bring it into the necessary level of compliance and safety. But is there anything you would like to talk about in your experience where upgrades are problematic?
Well, now, of course, the term upgrades often means two different things on either side of the pond. But as we mentioned before, anytime workers are at a site, any construction site, there is a minimum safety standard that they are relying on. And unless there is a written work procedure that tells them how to verify that before they start work, there is an unknown area they're entering in, relying on an assumption that they are safe. So this gets worse. By upgrades, a term, I would refer to that as an increase in available fault current as well. So that's now double jeopardy, right? We're there to do work relying upon earth grounds that we haven't verified. And if we're increasing available fault current, when we leave, we may be increasing a hazard level to our customer.
Very
Is that
true.
where you were going?
I think there was also the relationship between power and telecoms as well.
Okay, yes. So this is where I get to throw Rylan under the bus. So my 35 years is in the power industry, where there's a certain attitude towards grounding. You may have mentioned that as the analog world, the rotary phone era, where Rylan spends a lot of time in the digital world, telecom, where one single outage can be a massive effect on cell phone users, the internet users. And what we have nowadays is, with grid modernization, this attempt to bring both of those worlds together and have a grid controlled by the communications industry. Now, that being said, a lot of the meetings I'm in, Rylan has bitten his tongue off trying not to respond to power utility approach to grounding. So at this point, Rylan, maybe you'd like to weigh in on the challenges that you see.
Well, I think one of the biggest things right now in the telecom industry is this big push for 5G. And so going through a lot of these different switches and facilities that different telecom providers have, especially in the US lately, is this massive push to ensure that their grounding and bonding is up to codes and standards and regulations. But when you hear codes, standards, and regulations in a telecom world, it's never the bare minimum. It's always the absolute best that they can provide. So we go into facilities and apply grounding and bonding, single point, potential grounding, things like that across these facilities, because it's not only all of us using a cell phone 24/7, it's also law enforcement communications, customs control. The Wi-Fi up on your airplane is often the equipment's housed in these facilities. So ensuring that these facilities are running 24/7 is very, very important. And I know Todd is probably excited to discuss a special switch we did in New York City, where where the guy's job was on the line, I think, if the facility went down for just a brief moment.
Yeah, that was a major telecom company. We did the first switch that they put in to serve New York City. And as Rylan mentioned, he was very quick to point out, if something goes wrong here, you'll be dealing with someone else. So they take their reliability rather seriously. And I guess it's also interesting to point out that 15 years later, we did the second switch for that same company serving New York City. And I think the point really is that if you find people that can help you with the reliability on very, very sensitive digital equipment, you know, then it's worth it to bring them back. And the other thing I wanted to say is that the extent that they go to be reliable far and away outstrips other sectors that we work in. They have literally spent hundreds of millions of dollars over many, many years to get a system like this as close to perfected as they can. And they, you know, they're very quick to tell you how much it is a minute if they're down. So I think we could all learn something from that. And as Chris pointed out earlier, you know, on our prior podcast, you know, the fact that the power utilities are now starting to put more sensitive equipment, you know, the smart network, if you will, it's coming. And I think that what they need to understand is the requirement for protection systems that go along with that. Yes, you can get a lot of interesting functionality out there, but devices that work well in the lab will not work the same way out on a structure in the middle of a lightning storm. I can assure you of that.
There's an interesting point there. We, I mean, Todd will remember this. A number of years ago, we went out to the Gambia. We were helping their national telecoms operator trying to update their earthing processes. A European company that will remain nameless, had previously gone out and had been rather ungenerous in their advice and had actually used it as an opportunity to sell an awful lot of unnecessary metal, which, yeah, with a few quick tweaks to their systems, again, starting with test the earth, is it safe, and moving on from there. And we just, you know, went day one, this is how we're going to approach a site, and this is how we're going to make these small modifications going on. One of the engineers there, whilst we were doing the training, we were there for a few weeks, said that for their rainy season, he lived in his car. He literally never got to go home because, I mean, again, anyone not familiar with the Gambia, it's a long, thin, well, it's not that long, but, you know, comparatively, it's very thin and it's around a river. If you look, you know, anyone who knows where Senegal is, look there and you're in the right region. Yeah, and this particular engineer slept in his car because their switches would just keep getting triggered, getting, you know, more, not quite to the point of being blown up, but all shorting out. And he just had to drive, because there was no bridge across the river anywhere, he had to keep driving the length twice wherever he was going. So he never got to go home. And it got to the sort of first storm season after we'd done our time there. And I got a phone call on about 9 o'clock on a Tuesday evening. And it was one of the friends that we made there. And he said, I'm at home. And you just think, wow, that's when these systems, which are critical, again, as I said, you know, in the Gambia, just like everywhere else, the telecommunications network is how you get help, how you get to places, even if it's just a case of to communicate with people you aren't near. It's a critical system, and this engineer didn't have to make that sacrifice anymore just by doing something a better way, using a better method, a better product. And yeah, we're really pleased that since that point, he's managed to stay at home in rainy season ever since.
That's pretty cool, but I'm going to throw my friend under the bus now, Mr. Watts, because well, I work on railways. Railways are safety and revenue critical. And the first time Mr. Watts walked on my railway, within about 3 hours, he'd shut a station down
Yeah, sorry.
for a number of hours, which was good because it was an electrical safety event. And that was when I decided never to allow John Ward anywhere near a railway station for fear of him shutting the entire network.
But it's all inclusive because everything's going down the Internet of Things. All of our, like, I mean, your infrastructure, Paul, is all going to be online. We need to maintain continuity, and continuity of supply is fundamental within our standard and across the board. And that is heavily reliant on the suitability of our earthing systems and that they will work. Because if they don't, then our devices will start disconnecting. You know, and we can't rely too much on monitoring, because all monitoring is going to do is tell us there's a problem. We have to engineer solutions and not just rely on monitoring. You know,
Yeah,
it's very relevant.
it's quite weird actually, because at the moment I'm dealing with Vodafone, who are a major radio network, and I'm currently telling them I'm going to be cutting their power off very soon because of the way they take power supplies off of railway stations isn't the best in the world. So they're all scurrying around trying to get better power supplies before I go and cut their wires. Not literally while they're live, but just switch their breakers off and say, no, you're not having a phone reception in just Tower Gateway where the Queen happens to reside now and again. You know, those sort of little small things. But yeah, it is weird how, and just based on what you've just said, as I was growing up, the power engineering fraternity, the utility world, the big distribution engineers, for them, grounding or earthing is big, dirty. They accept there's things like harmonics. They accept large volumes of current on their grounding conductors, and as long as they have a relative level of control, they're happy with it. But then entree the telecoms engineers that needs a very defined low impedance. They want, I mean, they used to call it clean, which is just insane because you don't wash earthing conductors, but they want clean, they want no magnetic interference. They don't want currents or voltages being induced onto their earthing systems. They want noise free, for want of a better term, so that they don't have any EMI coupling issues which come from the grander scheme of EMC. And it's important because those small little electricery things that are the world of telecoms, they are now being more prevalent into having greater understanding and control and monitoring of the larger systems and the full integration of the grid, the local distribution, the prosumer, where the domestic homeowner is producing energy, exporting it to the grid, importing it from the grid, how that's all assessed, managed, controlled, synchronized, because obviously all of these waveforms need to be completely synchronized. There needs to be demand capability analysis. All that sort of stuff is incredibly intelligent, and we're heading that way whether anybody likes it or not. But we've got to make sure locally the safety is there.
Yeah, there are big questions about that, certainly domestically, and I imagine it's going to become increasingly apparent in the Americas as EVs and the kind of vehicle to grid as a concept grows more over there too. Because as Dave was saying a little bit back, you know, we've got the Internet of Things, we've now got the extending the power network, and it all being smart and communicable, usually controlled through mobile phones as well. You know, our reliance on these systems, be they telecoms, be they power, be they both, are increasing to a point, you know, in their saturation. And, you know, if they are still all relying on throwing electrical current back down the line, it's got to discharge somewhere in the event of a fault.
Yeah, and if you don't mind me saying, so we're currently, John's our expert on this. JW is we're heading into the world of Amendment 2 of the wiring regulations over here, and we're introducing the rise of the prosumer, which we've been talking about for years, in fairness. But where are you guys in America with all this? Are you ahead of us? Do you have prosumer installations where people are now allowed to operate their domestic installations without the grid being connected? Is that a real thing over there?
You're talking standalone or having off the
Yeah.
grid?
Yeah. So basically, someone who produces and consumes in Europe and the UK, we call a producer and a consumer a prosumer. Someone obviously had a play on words there, but effectively, what happens at the moment is if I have solar on my house and I lose the grid, then my solar inverter will switch off. I can't have power. But what a prosumer is allowing is for us to, when the grid switches off, still consume and utilize that power. You guys have that over there? Are you a little bit more advanced with it?
Well, in Canada, we call that net metering, where they have 2 meters on the house, and if you're generating enough to sell back on the grid, you get revenue from that. If the grid collapses, it doesn't matter. If you have enough generation, your electricity stays on, et cetera, et cetera.
Can homes store energy in batteries and things?
If you can afford a Tesla battery, you can store as much as you want.
Nice.
So that's the key, right? So it gets a little bit more complicated as you move south of the border. You're now into individual states and legislation, and there's quite a battle right now south of the border on the ability to do just what you're talking about. So one note I meant to bring up here when we were talking telecom and power industry and lightning, I do recall an event, I think just recently, one of the large blackouts in the UK, I think was due to one lightning strike on one of the interconnected transmission systems.
Yeah,
is that correct?
This was National Grid, was August 2019.
Okay.
A lightning storm triggered a series of outages, which again, this is more your area of expertise, I guess, Paul. Much of the southeast was in darkness, and you've got tube stations with people being guided out with torches and so on.
That's right. This is the one where, they had pictures on the news of Charing Cross where people were using their mobile phones for emergency lights because none of the emergency lights worked.
Exactly what you were saying earlier about emergency lights.
National Grid outages are great at showing how bad installations are designed and maintained. Not good for the end user and the owner of the building, because they end up getting a reprimand from the local authorities for not having necessary safety systems. But this is why in the UK now, when you do new builds or new railway stations even, we do something called a blackout test or a black building test, where you simulate grid failure completely, and then you go around and you assess the critical systems to allow that building to function and evacuate. And
but to be fair, any building that occupies a huge number of personnel at any one time should always be subject to that kind of phenomena.
You'll be surprised.
You're going to be heavily reliant on the electrical system to actually cope, to allow the persons out safely. Then that should be a standard procedure of commissioning a system.
It's not, Dave. Not in the UK.
I know. Not a should-have. Not a should-have, would-have. But yeah,
it's where we get rid of shoulds and turn them into musts.
Yes.
Not to go all Tony Robbins about it, but it's there. Whilst ever it's a should, it's a won't. When it becomes a must, then it happens. And in the electrical industry, we're really good at shoulds and not great at musts.
I don't disagree with that, actually.
So moving forward, we're going to be talking a lot about the idea of foundation of the electrodes and establishing that in our systems, moving through future amendments, and huge push on EV. Now, with regards to the actual Conjudisk combined with the Conjucrete, it looks fairly evident that's a safe method of installing thing onto a new home or onto an existing home even. So you can then actually, instead of burying electrodes in the ground, you can actually put in a much safer system. Do you think that there will be potential huge demand for these coming forward?
Well, there already is, certainly when it comes to domestic stuff.
Awesome.
We've been working with a number of home builders for a few years, providing a local earth, and oftentimes that's done via Conjucrete. I mean, it's utilising a method we developed for one of the large domestic telecoms operators, for their broadband infrastructure, where again they've been experiencing huge failures and reliance on RCDs and so on, which had to be maintained and checked every 3 months and so on. And it was just, again, that was the case. If you're already digging the foundation, let's dig an extra 100 mil. We'll put in a thin wire to interconnect into the earth point. And that was buried in 50 mil of Conjucrete, and simply hand shovel on an extra 50 mil of excavated material, compress that down. Again, this is all stuff that literally takes, I mean, I've done these demos in less than 5 minutes.
Yeah.
Then, yeah, just carry on the installation as normal. And the weight of that material going on top of it further compresses the Conjucrete down. It's there's no water additive on most of the installations because it's just going to absorb the water from the surrounding mass of earth. Yeah, process takes minutes and it ends up with a highly functional earth. And overall, we got to 100% safety, no need for RCDs using that method for the large telecom.
Well, so you're able to achieve a good enough impedance that overrules the need for RCDs even.
Yeah, absolutely, yeah. Because again, the in-life costs associated with RCDs meant, you know, that every year this earth system increased in cost, whereas ours every year got cheaper because you were able to amortize that capital expenditure over the entire life of service life of the earth electrode.
And so by using Conjucrete with that, you can guarantee the life of that connection of an earth over a good period, which means you could pretty much assure the fault currents for the equivalent of TN systems that we have in the regs. So you don't need the RCD requirements of TT systems, because it does say in our regs that if you could achieve those impedances on TT systems, you don't need RCDs.
Correct. And that's where we went with that particular system. And it was a transferable methodology. It's a case of, right, you know, you're digging foundations for houses, you know, you've remediated the ground, you've excavated everything. Right. Okay. You've got to.
But I think more fundamentally, you actually de-skill the operation. Before, the people digging the holes literally had the responsibility of driving the electrodes, and they didn't have the skill set to achieve that safely. But those same guys now using the Conjucrete solution, it not only speeded up the installation, we did a time and motion. The conventional method was 3 3/4 hours. Now our solution from start to finish, 37 minutes. And whereas the conventional only achieved 117 ohms, we had to get down below 20 ohms, which, as it turned out, was down to 16.3 ohms in 37 minutes.
And, you know, like John was saying, you know, this is just, you know, oftentimes the job of an electrician in those large scale networks is being done by a civils engineer. And there is no sort of discredit from my side where it's a case of, you know, I'm glad I don't have to dig holes, but when it's a case of the person who's digging the hole is now responsible for electrical safety, well, that's a responsibility too far. And this is where it's a case of, you know how to dig holes and fill holes. Well, we're going to make sure that what you fill it with is going to do the job, so you don't have to do any thinking with it.
So glad they don't have a strong union on the civil engineering fraternity, because what are you trying to do? Take away their concrete? No, I personally love it. We had a civil engineer on the podcast, funny enough, a guy called Colin, and I call him a concrete farmer. Dig holes, fill it with concrete. How hard can it be? Put a bit of steel and glass in it now and again. That's about it. But just on that, Dave, you said, is there a use for it? Yes, on my driveway, because I have to renew my driveway, and I'm thinking about putting in a full rebar support system, and I'm thinking of maybe using that as part of the substrate to give me a phenomenal earthing. So yeah, I'll have about 40 bags, please.
Yeah, no problem.
There's another funny incident. There was again a major broadband installer in the UK. We did the same solution, what we tried with the telecoms, and one of the things they were concerned about was protecting the cable from the electrode to the cabinet, because what I told them, you don't need that. Strip off the PVC off your cable so it's bare, and pour the Conjucrete over. The resistance dropped down from 123 ohms down to 15 ohms, and I said that it will go lower up to 28 days because it will continue to absorb the moisture and lower the resistance. I said, very good. So 28 days later, we're back on that side. The resistance had dropped down below 11 ohms now, and they were very, very happy. And they turned around to the guy with the spade to dig it up, see if he can damage it. It was to go in great guns until it hit the Conjucrete. He nearly broke his wrist.
Actually, talking about that method of just stripping back the wire, John, the other week we had an EV installation company based in the Lake District take on a Conjucrete. They were used to using rods and didn't enjoy them. Again, I don't necessarily see what there is to enjoy about a rod, but they wanted to try something different. So they took on a Conjucrete and a couple of bags of Conjucrete. And yeah, again, John, did you want to take over on this one? Because you actually took the call.
The problem with the Lake District, there's a lot of rock below the surface. So we knew it was going to be challenging. So we said to the chap, right, we'll give you a Conjucrete, right, and we'll give you 2 bags of Conjucrete. 1 bag below the disc, 1 above. He was struggling to get the resistance, target resistance. So I phoned him up and he says, well, I've only used 1 bag. I says, well, yeah, you didn't follow what we said we're going to do. It is a challenging environment in the Lake District. So I said, look, I'll tell you what, strip back the PVC on the interconnecting cable out of the Conjucrete, and the other bag that we gave you, right, wrap the bare cable around the concrete. I said, don't test it immediately. Give it a few days to soak. And 3 days later, I called him up and I says, how do you do? He says, we achieved 50 ohms lower than what we were looking for. And that's in the Lake District.
John, just finish off that story. What happened with the rod?
Oh, right, yeah. He says, just as a comparison, that they decided to drive an Electrode. And then they tested it, 1200 ohms.
Wow.
Yeah. I think the point, if you don't mind me interjecting, I think the point is one of the reasons why we asked you guys on here was because one of my biggest fears, we mentioned this on an earlier podcast, was with the EV gold rush for EV installs. We are at danger of lots of nefarious people going out employing groundworks labourers to dig holes, stick rods in unsafely, end up putting them too near PME supplies, etc., introducing all sorts of unknown hazards that they don't have the skill sets to understand. Whereas this, for me, is innovation. The Conjucrete, the Conjucrete, it's basically a local earth reference that you can implement anywhere to enhance the safety of the equipment, the installation, and the user. So it's an absolute no-brainer, and yet electricians in the UK don't know about it. So
this is true.
For anyone listening, go out and learn about it, and maybe talk to your wholesalers. Or go online. In fact, guys, where actually can we find you online? Tell us where we can find you.
The easiest place to find us, whilst we're active on the likes of the social media platforms, the easiest way is earthingservices.com. Just all one word, no fancy punctuation. earthingservices.com, and you'll find also links to the social media from that webpage anyway. But yeah, you'll learn a little bit more about why the products work, why they aren't equivalent to, other, what people might perceive as semi-comparable or whatever. They're really, you can find out an awful lot there. You can, and also it's a great way just to click that, contact us, and get in touch, because we're always happy to talk to people. And we always, our customers will bear us out on this. I'm certain of it. We aren't here to extract as much money from every customer as possible. That isn't our philosophy, because one thing's for sure, as much as people may not be aware of some of our innovations, they do know when they feel like someone might have been taking advantage of them, and we're keenly aware of that, so we don't do it. So our approach is, what are you doing, and let's figure out the cheapest way we can do this for you. Because if we can not only come up with, a 60+ year solution for the actual earthing, and do it in a really simple way that's really time effective, if we've managed to save them money in the process as well, then the next time they come across an earth problem, they're going to pick up the phone. Or if we're just going to be the name at the end of the tongue, and that's a place we like to be. We like to help people, we like to solve problems, and yeah, we've got the equipment to do it.
I'm just going to add to that as well. There's a reason why I'm very selective on which manufacturers come on this podcast. I actually like the ones that are open and honest and transparent, and like to work from the regulations and go above and beyond the minimum, which, to be perfectly frank, the minimum is a load of rubbish. And I've always said the minimum is set by people who are too scared because they're scared someone's going to give them a kicking for costing someone money. When it comes to safety systems, services, safety doesn't have a cost to me, to be honest with you, and this looks like real innovation. So I'm really hoping that when people listen to this, they make their own assumption and they go out and they get in touch and they try some Conjucrete. They try to look at going away from earth rods and into these discs. We know that there are EV charger manufacturers out there who are selling their wares as earth rodless, which is a bit naughty considering that the DNOs may not necessarily agree with that. Neither does the IET Code of Practice for EV.
Yeah.
But that's a whole nother discussion for a whole nother day.
Let's just say I don't think the book is closed on that one. You know, looking at the latest documents coming from the distributors.
Mm-hmm.
The thing is, the conduit is not just, we call it the universal solution, the universal electrode. It's not just EV charge points. Another example would be LV pot ends. You know, currently the DNOs or the independent DNOs, they drive rods or supposedly drive electrodes.
I've never seen
But that is another solution where the conduit is already terminated, dropped in the ground, forget it, fit and forget.
Also, if you don't mind me saying, feeder pillars and lighting columns, where there's a requirement for additional electrodes at feeder pillars and end of line lighting column systems. This would be a far more cost effective way, I'm assuming.
Yeah, exactly.
Yeah, definitely.
It's a solution where it's fit and forget. Once it's in the ground and terminated to whatever it's going to be connected to, with a life expectancy up to 60 years, that would probably survive the life of the whatever it's protecting.
So, Mr. Ward, I was going to ask John what his thoughts on all of the shenanigans we've been talking about on this, because the quieter he is, the more he's thinking about things.
Yeah, I mean,
John.
This whole EV thing, electric vehicle thing, is a bit of a mess at the moment, and it's probably going to continue to be a mess because there are certain manufacturers who've got these devices which they claim don't need any kind of earth connection, and some are considerably worse and better than others. So don't necessarily believe everything you read from certain manufacturers. And of course, people just going around sort of banging in rods all over the place because that's basically what they were taught is completely unacceptable in a lot of cases, because you've got no idea what's in the ground, you've got no idea what you're poking it into, and even if you put your rods in, you can end up with a complete mess anyhow. Sort of, put the rod in and it measures 1,000 ohms, so that was a waste of time, wasn't it? So, and the other thing I think as well, that on certainly a lot of new properties, all the services coming in, like the gas and the water, which were traditionally metal and were all bonded together, they're all plastic now. And you've got the existing properties where they were metal, and then they've been replaced with plastic. So although they weren't put there as an earthing solution, it obviously is still connected to it, and it was all connected to it. But of course, you're taking that away and putting it as plastic. You're now relying in most residential properties that cable coming in from the supplier. And if that's some 70-year-old lead-covered piece that's rotted away, you don't have an earth anymore. So putting this sort of stuff in as a standard solution, I think is going to be a big deal in the future. So
I think that's a valid point, actually, John. So for our friends from Canada, especially in England, many years ago, when the network was laid, it was a beautiful separated earth neutral system wrapped in lead. We had lead water mains, we had cast iron gas, and obviously if there ever was an issue on the network, just fortuitously, it would earth via the gas, the bonds on the water and the gas. The trouble is over the years that's corroded, and they've replaced it with MDPE plastic pipes. So obviously the minute you've taken away these huge supplementary electrodes, which now means there's more strain and more junk going down where it should have gone in the first place, you then add to that the fact that we've gone from resistive and inductive loads to electronic and capacitive and all this other junk, we've now got to deal with harmonics and earth leakage and residual currents and all sorts of shenanigans that the network isn't coped for. And we've now got this G55 standard coming from the DNO that's looking at emissions of an electrical installation, which then links into EMC, and it becomes just this, whatever good we do comes something else. And what I like about this is the Conjudisc and the Conjucrete, there's a good, but I'm not seeing the negatives. I'm only seeing a betterment over what we have with the nuisance that is rods. Safer, longer life, better materials, lower impedances over time. I don't see a negative to this. So, and if anybody does, feel free to put a comment below or get in touch.
Let us know.
Yeah.
Right, chaps. Do you have, I'm going to ask because I'm just purely selfishly, do you have any other awesomely wicked products that you want to tell us about, or any secret things up your sleeve that you can maybe reveal or not?
Well, Todd, why don't you take it?
Sure. Well, I think, Rylan, I'm going to hand it over to you so you can talk about Conduform and perhaps Conduflow, our liquid backfill.
Sure. So, as an alternative to Conjucrete, we've come up with a couple solutions. One of the reasons with Conjucrete is it's a powder. So in certain areas, if you're dumping it into a deep hole, it can be very dusty. As well as areas if it's very remote. Trying to mix Conjucrete as a slurry, if that's a requirement based on the terrain, it's just difficult to get water to site. So an alternative we've come up with there is called Conduflow, and it's supplied in a 5-gallon pail. Comes with a little curing agent that you add on site. You mix it up, and you can pour it into a hole or into a trench onto a conductor. Already has water content in it, so there's no need to add any. There's no need to wait for it to absorb, especially if you're in dry and rocky soils where it won't absorb very well. The other benefit there, the Conduform, which is essentially just a thicker version of Conduflow. So Conduflow, you can very easily pour it out of the pail onto the conductor, whereas with the Conduform, it's more of a mortar type material. And we use this material where you come into contact with exposed bedrock or rocky fill, and you're trying to get a ground connection. So one of the biggest problems with rock is if you lay a conductor sitting on top of rock, the surface area contact between a round wire and that rock would be very minimal. So when we add this conductive material around it, we create a significantly better bond. And so again, if you have exposed bedrock, you can take this material, the mortar-like material, pour it on top of the conductor, form it so it creates a bit of a mound around it, and it'll set up as a solid and also protect that conductor from weather, environmental conditions, and anybody trying to steal the conductor because it's exposed as well. So I think those are the main points on Conduflow and Conduform. I'm not sure, Todd, if I missed anything there.
No, I think that was just fine. Basically, with respect to the exposed rock, what we found is that while you can mix Conjucrete into a mortar form, we just wanted to have something that was simpler to allow us to bond to bedrock. So let's face it, a lot of times, you're out there and there's no soil. And so we recognize that, especially on transmission lines and that sort of thing. You could have miles of it. So we just decided that, something better needed to be developed. So that's what we've done. We've actually trialed this. We did something in central Canada and it was on granite. And when we laid out 150 meters of copper right on the rock, we measured that at over 1,000 ohms. And then we put the Conduform on top of it and measured it again right away, and it dropped to 230 ohms. And then a few weeks later, after someone went back to finish the work and everything, of course, had cured, it went to just over 100 ohms. And so what the reality is that the contact, as Rylan mentioned, with the rock between the copper conductor and the rock is minimal. And when you then put the condu form on it and completely bond it its entire length, and I guess we had, I don't know, 8 inches. What's that in metric, everybody? I'm not sure, but
200 mil.
there we go. We had, you know, we basically made an electrode that had perfect contact with the rock, and that's how you explain these large differences. So, you know, this is the kind of behavior you'll see from our company. We try to look for practical ways to solve these problems, and this liquid backfill is just another you know, another example of that.
Hey, Todd.
I was going to ask a question, but I've just read it on your document. So it actually is it's protected against freeze-thaw erosion.
Yeah, so interestingly enough, we did 30 years of freeze-thaw cycling on it, and the resistance to ground actually drops. And of course, in our part of the world, we have to be very concerned about freeze-thaw because of the temperature issues that the cold temperatures that we face. But it is a very durable product from that point of view.
It was an assumption I'd made because obviously being mounted onto some surface rock material. I thought I'd be subject to that, but no, sorry, Karen.
Yeah, no, it's a good question.
I was just going to say before, I would like us to mention the marine electrode, but before I kind of want to tee that up, and then I'm going to run off because I've just realised I have a disc downstairs with a cross section, so we can show you a Conjudisk, so that anyone watching this can actually see what one looks inside, kind of underneath its skirts. So I'll be back in just 1 minute.
Yeah, go for it. So what I'm hearing here, which is mind-blowing in itself, is with some of the products and services, you've not only got your Conjucrete, but you've got alternatives that allow you to adapt earthing to any type of terrain. Effectively, for the layman here, you are creating earthing where it's virtually impossible to create earthing.
I think the key is you're engineering your terrain.
Wow. Right, that's right. Yeah, we
very Ridley Scott of you.
We actually, when we did that trial that I just mentioned, we were expecting improvement, a dramatic improvement, but this went beyond expectations, and then we had to actually analyze how it could be so different. And what you have to remember, on top of the small surface contact you get with a round cable on rock, you have to remember that the rock undulates. So you have a lot of spots in a rough terrain where the copper is literally not touching the ground. So when you combine these things and you make sure you bond directly to the rock, those issues are resolved, and the larger surface contact gives you dramatically better values. So it is a reality we all face. You know, what do you do on solid rock? So that's why we've been working on that. And then the flow, originally the flow was designed to go with the disc at the bottom of distribution line poles. And you know, some of the people, as Rylan mentioned, were not happy when you start trying to dump a fine powder down, you know, 6 feet into the ground. You get a plume, and nuisance dust masks deal with that. But you know, we got asked by one of our major customers, "Can you make us a liquid?" And so we made the liquid, and that's, you know, some consider it much easier to deal with the pole grounding that way. But what we also have found out is you can use the condu flow in trenches just the way you use the Conjucrete. And recent testing we did showed a dramatic immediate improvement over Conjucrete for that application. And of course, that's because the material is liquid, and it will bond even better to the soil very quickly than Conjucrete does. I mean, over time, they'll get closer together in value, but the immediacy of the performance of the liquid in a trench was also very interesting for us to observe.
Do Conjuflow and Conjuform have the same kind of life expectancy as Conjucrete with regards to what we can expect for a life cycle of the system?
Yeah, they do, and you know, the advantage, of course, for Conjucrete is it's lower in price.
Yeah.
But it's, you know, we actually did a trial for a U.S. utility some months ago, and they had rock slopes that were 45 degrees. And so they wanted to try a bare wire, they wanted to try regular concrete, and then they tried the Conjuform. Well, the only one, of course, that was successful was the Conjuform, and the regular concrete literally slid off the slope on the rock. It just slid right off. So, you know, if you think about it, you can virtually put this material vertically. We've actually stuck the Conjuform to the side of a boulder, and it doesn't come off. So, wow. In these extreme situations, it's well worth it to use that type of material for those types of extreme environments where other materials, you know, they're just going to slide right off.
I'm starting to believe the slogan "It can be done" now, Paul.
Yeah, well, I'm going to segue this because obviously time is pressing on, and what I want to do is talk about one thing which I know Sean is very keen to talk about. I work obviously on a railway which is very much marina based. It's tidal. I have always, for many, many years, I mean, we're an island, for God's sake. So corrosion is a massive, massive problem that our industry and our regulations don't do enough to inform the end contractor, the electrician, as to how to look and identify and select the right materials to try and prevent corrosion and get the intended life for the asset. Sean, you've got something you're going to tell us about now.
Okay, me.
Yeah.
Well, I was going to say I've prepped up the disc, if you like that.
Oh,
there's the disc.
Wow.
So, and in terms of what it looks like in the middle, is one we sawed in half earlier.
Before John says it, just send it to him and he'll set fire to it, blow it up, stick it in a nuclear reactor.
No problem. You see how you can break it. We like to find out. So
don't challenge John. He'll find a way.
So the marine electrode, I guess, Paul, is what you were asking about. What we recognize actually in some of our trials in Canada was that just the mere fact of putting in an electrode in the water far and away outperformed anything we could do on the land, of you know, even when the footprint was dramatically better. So if you can imagine a 6-foot long precast electrode, 4 inches in diameter, and literally just dropping it in fresh water, where we had, you know, hundreds of ohms with a land-based electrode, we then we got I think just over 50 ohms with one electrode in a lake. So of course, then people start asking us, when you call something marine electrode, for most of the world, that's a saltwater environment. And the original electrode, which we called a marine electrode, was for freshwater, which we have mostly around us here in Ontario. So then we went back to the drawing board and designed one that will also work in seawater. And of course, seawater is highly conductive, but very, very corrosive. So with our background in grounding and corrosion control, we've developed an electrode that you can deploy in salt water as well. And of course, with the level of conductivity, that would be highly effective pretty much immediately. So yeah, there are situations where you're in extreme environments, the land isn't going to provide much of a ground for you, and you can use you know, a marine electrode, and in no time those are generally completely embedded in the sea floor, so they're not a problem from a safety perspective either.
I was going to say there's it's not often reported, but again, I think this is the sort of thing I might throw at Chris, so you might need to prepare yourself and unmute. But drowning through electrocution in marinas, that's something that, you know, again, it wasn't something I'd really heard of until Chris sent me an email that frightened me.
I'm good at frightening a lot of people.
So are we.
You're 100% correct. Even an experience in the utility that I retired from, I wouldn't say electrocution, but public contact and waterways was what brought me into the world of grounding, and I've never escaped. So the more yeah, and of course that did introduce me to Todd, and I'm still paying for that as well. But you will find out that water can be your friend and or your enemy. And we actually were just in the U.S. and another state to do with an issue of voltage on aluminum docks, et cetera, et cetera. So there's a number of key issues there that can be solved with appropriate use of our fresh water or saltwater electrode. But the key, and I circle back to this the same as everyone here, is getting the appropriate information from the customer or the people involved so that you can determine the correct application. And I would circle back just while I think of it before I forget. Ryland did briefly mention copper theft, but for Paul there in the railway business and the rest of us in the utility business, we all know when the price of scrap copper goes up because we are blanketed with problems. Right, and if I can share a quick story from an unnamed state utility in the US, copper theft was so bad where they were, they had a specific truck that would leave an operations center to go back and replace copper jumpers. And they quickly realized they were being followed by the crew that was actually stealing them, right? So what they learned to do was replace the jumper and leave another jumper beside the structure for the thieves to quickly take, and they could maintain electrical integrity. So they switched to conduform to stop that theft process. And of course, once conduform is put over that jumper, or whether it's in a substation, the railway, the thieves, that's too much work, and they immediately move on to the neighboring utility or railway to steal their product.
Yeah, that's a point. I mean, again, Paul, I'm sure you'll correct me, but I seem to recall that according to the British Transport Police, that copper theft was second only to terrorism in terms of threats on the railway.
Yeah, pretty much. I mean, they've tried changing stuff for aluminium, but the fact of the matter is they still will steal it. I mean, on the railways, for instance, we don't use, we're moving away from the use of green and yellow to identify our earthing conductors and just stick them with black, because then the thieves don't know whether it's a green and yellow conductor or a power conductor, which could really hurt them. Although if they understood anything about railway electrics, you cut any cable and very high chance it's going to go bang. But yeah, it is a problem.
Well, we had a similar problem in the UK, didn't we, Sean, where literally 12 hours before they're doing a dead short test on the tram system from Manchester to Rochdale, they removed 12 kilometres of traction bonding.
Wow, that's not unheard of. That's not unheard of. I know of a similar railway where 10 kilometres of traction return was stolen. Literally, somebody just went in, tied onto the cable, snipped it, and just pulled it straight off. Nicked the whole section overnight. So,
Sean had to
serious guts to do that sort of thing.
Yeah, Sean had to go with the crew at 3 o'clock the following morning up to Manchester to replace 12 kilometres of traction bonding.
Yeah, it is a problem. They have tried changing it in the UK, because now if you have large amounts of cable scrap, you have to have a letter of authority. Everything's recorded now. All new cables are stamped. You can get then these dies as well, which like have these weird tags in them, so you can tell where it was installed and who owns it and double check. But then again, all you got to do is just get the apprentice to strip it all back to bare metal and chop it into sections, and nobody knows where it comes from. So
I think usually it's petrol in the match.
Yes.
Just burn it off.
There you go. There you go. I didn't know that. Note that one down, lads.
Well, this is one where, again, not so easy if it's covered in conjuform.
No, very true. Very true. Right, gents, I think it's about the end of round 2 for us. This has been, to say, insightful. So what I'm going to do is I'm going to ask my tag team partners if you've got any other questions to start with.
But quick question. Is the Conjudisk pretty good as an electrode without the use of Conjucrete?
Yes.
The reason I ask is I do a lot of work in temporary installations and events where we have generators delivered. And often the generator company will provide the electrode, and what will happen is the electrode will just be stuck, probably pushed about 200 mil in the ground and just flapping in the air like that.
Yeah, yeah.
And then we've got to make the decision as to whether to bury that or to just remove it altogether. Most of the time we don't need the earth, sometimes when we do. I might get one of these and test this out because I think this is a great solution for generator earthing for temporary systems.
I think so as well.
Yeah, we've used it for that. We've got, again, without naming the project, temporary generators for a large construction project. And yeah, but the good thing about this, sorry, I say this and I'm gesturing at something no one else can see. So about the disc is that because you're not burying it in the ground, to anything like the extent you drive a rod, removing it's not a problem at all.
Exactly.
It's easy. And indeed, if you're talking about temporary thing, we say 600 mil, and just so this one's covered, we say 600 mil so it complies with the earthing standards. If you're talking about permanent earthing, they're saying get it to 600 mil because that's going to be beneath the permafrost. The freeze depth over winter. But if you're only doing temporary earthing, then you probably don't need to worry about getting it that deep. And secondarily, if you've driven a rod, then you aren't going to extract that.
Well, that's the point. That's why they don't drive them. They just leave them sticking out the ground like this.
Exactly. So, but with a disc, because you're not going to have to go to the same extent, you're still going to have the contact surface area equivalent to a 3 meter rod. And then just you pop it out of the ground, next location, drop it back in. So it's sort of recyclable earthing as opposed to, the only place that an earth rod will go is the scrapyard at best, if it's still, if there is anything left. Or chances are, as John alluded to earlier, a lot of people will probably, if they're going to do anything with it, they might lie it down on the surface or in a small trench. And we were involved in some competitive testing with the Conjudisk and driving an earth rod and laying an earth rod down in an excavation. And anyone who thinks that laying a horizontal earth rod is equivalent to driving it, it just isn't. It doesn't achieve anything like the resistance. It's one of those frightening disparities. But again, it's grandfathered down, apprentice learns, oh, right, all we do is just lay that rod down and it's done. It just doesn't work.
But as you said earlier, it's time for us to think better and think about moving, doing more suitable solutions. And to me, I'm looking at this Conjudisk. If I was to get some HO7 and get a temporary, permanent connection on that, and then just take that from one site to the other, I think that's a great temporary earthing solution for the systems that I work with.
I think what Dave is trying to say is, can you send him that before he goes out and does all his Christmas temporaries?
Absolutely.
Well, actually, next week I'm commissioning a load for the National Trust down south, and I'm doing Kew Gardens, and there are going to be loads of electrodes just sat like this at the ground for me to look at and determine how good an earthing that is.
Can you
be thinking about this?
Tell one of them to him.
All week next week.
Just you give me a delivery
play around
address and
with
you'll get it.
And then Dave, you can put some videos on Instagram as to
if you want to send
because at least you've got a garden to bury it in. Kew Gardens, you're not going to get any better than that.
I'll put it in there and see what we get.
Just don't
I
ruin.
think we got one in
Buckingham
Palace actually. But that's a separate story.
Yeah,
nice.
But no, I think temporary installation. This would be something people should be looking at. And I'll be messaging a couple of companies that manufacture the distro, and because if they can make the connection for this, it'll just it's a good sensible solution.
No problem, Dave. Just drop us a delivery address.
John Ward, final thoughts.
Yeah, I think that the disc in particular is going to be pretty much the default choice for putting things like electric vehicle charging in, because it's just so much quicker, and it's also immediate, because on a lot of smaller jobs you don't necessarily have the time to go back, say, a month later and then test it to see how it's improved. So the fact that it can be done like instantly almost, so particularly on like domestic installations, you could just, if you're going to put an EV charger in, that's likely to be finished and done within a day, and you don't really want to be going back, say, a month later to test that the earth is either improved or whatever, because that's going to add extra cost anyhow. So the fact you can just put it in, it's done, and then that's it. That's perfect for that. So.
Yeah, there's definitely a safety and a time quality thing, and more importantly as well, when you're putting on your test results, resistance of RA, you can put whatever the reading is, and then a little note says when you check it, it will be lower for the next bloke. That'd be pretty cool.
Yeah.
That'd be pretty cool. But yeah, no, I think, guys, I think what we've seen here is great. Now, over to the Earthing Services and SAE guys. Do you have any questions for us or any final thoughts before we wind this up?
Well, obviously to say thank you for having us. You know, it's a real pleasure to talk about this sort of stuff with people who recognise the inherent challenges in the industry, and that sometimes we are going to have to do things a little bit differently to improve the situation. So yeah, thank you very much for having us. And just anyone listening, if you're installing an earthing system or you're relying on an existing system, please test it and please take all safety precautions, because if it's not something that's got the lifespan of our range, then you can't just trust it's there. It's too important for that. It's getting home at night, and that nothing can be more important than that.
Totally agree. Any other thoughts, guys? Todd, John, Chris,
Well,
Rylan?
no, I think it's been a very good meeting that we had. Really enjoyed it.
Okie doke. Right. Well,
Thanks for having us.
on behalf
guys.
of all the E5 guys, Todd, Sean, Chris, John and Rylan, thank you very much for joining us. It's been educational. It's nice to see, even though there's a big pond between us, that there are lots of people still very passionate about the system that is known as earthing and bonding, or grounding in your case, and bonding. But yeah, other than that, really, guys, if you're listening or watching, thank you. You can find these guys at earthingservices.com. If you want to do the likes and subscribe stuff, because I've got Dan in my head telling me to do that, then that's great as well. And I genuinely think, after listening to these chaps for the last 2 hours, I think it can be done. And you guys definitely are the definition of earthing innovation, because I'm hoping that the people listening to this will be going, oh, I've just thought of a whole new way of doing earthing. Cool, this is going to save me money, my clients money. Brilliant.
I just love that we've not talked about technology, devices. I just love that we've not talked about brand new devices that are going to be magical and, you know, maintenance free and all that nonsense. These are engineering solutions.
Yes. So
Very refreshing.
On that bombshell, gents, thank you very much. Thank you, everyone, for listening. And until the next one, or whenever it is, take care of yourself and each other. Bye-bye.
Cheers, bye.